Section 12.2b is about taking the rational expressions we've been using and simplifying them. Here's the key to the whole section. To simplify a rational expression, you must eliminate any common factors of the numerator and the denominator. So we're going to do some canceling, some factoring. We'll start with this as our first example. I like to break it up into separate fractions. I find that a lot easier to deal with. A to the second over a to the fifth, and b to the third over b. This is actually a review of the exponent rules that we've learned in the past. Here, 7 and 21 will reduce to a negative 1/3. When you divide bases that are the same, you subtract the exponents. So here we're going to get a to the negative third, but we can't have an a to the negative third, so we're going to put it on the bottom of the fraction and make it an a to the positive third, putting it underneath 1. Here we get b to the second, which is okay, so we just leave that as b to the second over 1. Now combining everything on the top, we get b to the second. On the bottom we get 3a cubed, and it's still going to be negative. Here's another expression to simplify, but we have the added instruction of finding the excluded values. So before I start canceling, I want to look and find what the excluded values are. Now I don't have any pluses or minuses here, so I need to think of any number that I could put in for x or y that will give me a 0. Well, when there's no pluses or minuses and everything's being multiplied, the only excluded values are this: x cannot be 0 and y cannot be 0. Because if those values were plugged in for x or y, it'd multiply by everything and give me a 0. So this is pretty easy for the excluded values. Now let's get to the simplifying part. So we'll first break it up into separate fractions, and then we'll reduce 56 and 70. Well, 14 goes into both of those numbers, but if you don't know that, maybe you can at least say that 2 goes into 56 28 times, and then 2 goes into 70 35 times. And then you might be able to see that 7 goes into 28 4 times, and into 35 5 times. So that's how that one reduces. Here we're going to subtract exponents. 2 minus 1 is negative 1, but we have to put that on the bottom because we can't have a negative exponent. And 1 minus 2 is negative 1, so again we put that on the bottom. 4 over 5xy is how this expression would simplify, and we've already said that the excluded values are 0 for x and y. Here's an example we want to simplify. The biggest mistake that I see when people come across this problem is they start to cancel things like x squared and x squared, x and x. They cancel 15 and 12 and get a 5 and a 4. You can't do that. You can't do any of that because you cannot cancel things that are not factors. And these little pieces are not factors. They are parts of a polynomial. So what we have to do with this is first we have to factor the top and the bottom, factor the numerator and the denominator. Then we can start looking at canceling. Well, on the top, we'll use a diamond. I want two factors of negative 15 that add to be negative 2. Looks like negative 5 and 3, so I'm going to factor the top. Let's move it over here to x minus 5 and x plus 3. Now the bottom is also a trinomial, so I'll use a diamond to factor that. Two factors of negative 12 that add to be negative 1. How about negative 4 and 3? So then this becomes an x minus 4 and an x plus 3. Here's where knowing how to factor trinomials fairly quickly is going to be beneficial for you. If you take a long time to do this, that's okay, but it's just going to take these problems a lot longer. So now that I've factored the top, I've broken them up into binomial factors. Now you can cancel factors. I can take this whole x plus 3 and cancel with an entire x plus 3. That's legal because they're being multiplied by the other binomials. Now I can't cancel the x and the x here because they're part of a polynomial, and so either I do the whole thing or none of it at all. So my final answer here is x minus 5 over x minus 4. That's how these two trinomials will simplify. Some more examples, but this time we have to also find the excluded values. And this is a key that I really want you to remember. I'd like you to find the excluded values after you factor. And the reason why, you'll see when I get to this example over here, you'll see why it's important to do that. But let's first start with this one. I want to factor the top and the bottom first. So the top here, this is not a trinomial, it's a difference of squares. X squared comes from an x, and 49 comes from a 7. So we do plus 7 and minus 7, and that's over x plus 7. So now that we've factored it, it's time to look for our excluded values. What values could I plug in for the denominator that would create a 0? Well, this one should be easy to see. It's negative 7. So we could say that x does not equal negative 7, or it should not equal that. That's the excluded value. Now we'll simplify. Because these are groups now, because they're binomial factors, I can cancel the x plus 7, leaving me with an x minus 7 as a simplified form. So this is the simplified form, and this is the excluded value. Over here, I'm going to need diamonds, 2 factors of negative 3 that add to be negative 2, negative 3 and 1, so x minus 3 on top, x plus 1. The other one, diamond, is factors of 12 that add to be negative 7. Negative 4 and negative 3, so x minus 4 and x minus 3. Here's where I want you to find the excluded values. And the reason is this. It's really hard for me to tell what my excluded values are when it's a trinomial, but it's a lot easier after I factor. Hopefully you can look now and say, what minus 4 is 0? Well, the answer is positive 4. So x cannot be positive 4, and x could not be positive 3. Those are the excluded values. I use the not equal to show that they should not equal those values. Now we'll finish simplifying. I see an x minus 3 and an x minus 3 that can be canceled because they're binomial factored. The rest has to stay this way, and so there's my simplified solution.